Greetings, curious minds from Science Aura. I'm Dr. Sachi Vale, and today we embark on a cosmic journey to ponder one of the universe's most profound mysteries, the Fermi Paradox. Look up at the night sky, a boundless tapestry woven with billions of galaxies, each home to billions of stars. Statistically, the sheer number suggests life should be abundant. Yet, as we gaze into this cosmic ocean, we find ourselves in an unsettling silence. Where is everyone? Why haven't we found any definitive proof of intelligent extraterrestrial life? The Fermi Paradox, named after physicist Enrico Fermi, highlights the stark contradiction between the high probability of extraterrestrial civilizations existing and the lack of observational evidence to support it. Given the age and size of the universe and the countless opportunities for life to emerge, it seems logical that advanced civilizations should be common. But our telescopes, our probes, our radio dishes, they all report back with silence. This profound silence is what we aim to explore today. To truly grasp the paradox, we must first appreciate the staggering scale. Our Milky Way galaxy alone contains an estimated 100 to 400 billion stars, and there are at least 2 trillion galaxies in the observable universe. Many of these stars are orbited by planets, with recent discoveries suggesting rocky, potentially habitable worlds are not uncommon. If even a tiny fraction of these planets harbored life, the cosmos should be teeming with it, perhaps even with intelligent beings. The Drake equation, formulated by astronomer Frank Drake, attempts to estimate the number of detectable extraterrestrial civilizations in our galaxy. While its variables are largely speculative, it serves as a framework to consider the factors involved: the rate of star formation, the fraction of stars with planets, the number of habitable planets, the fraction that develop life, intelligent life, and technology, and finally, the lifetime of such civilizations. Even conservative estimates often yield a large number. So, if the numbers suggest a vibrant, populated cosmos, why the deafening silence? This is the heart of the Fermi Paradox. Are our assumptions flawed? Is there a fundamental barrier to the emergence or longevity of advanced civilizations? Or are we simply looking in the wrong places? Or perhaps not equipped to perceive what's truly out there? Today, we'll delve into the most compelling hypotheses, attempting to resolve this cosmic enigma, while exploring possibilities from the mundane to the truly terrifying. One of the most compelling, and perhaps unsettling, explanations for the Fermi Paradox is the Great Filter hypothesis. This theory suggests that at some point in the evolution of life, from its earliest beginnings to an advanced interstellar traveling civilization, there exists a formidable barrier or filter that is extremely difficult for life to overcome. This filter acts as a bottleneck, dramatically reducing the number of civilizations that reach a stage where they could communicate or travel across the galaxy. The terrifying aspect of the Great Filter is its potential location in time. Is it behind us, in our past, meaning humanity has already overcome it? Or is it still ahead of us, a looming threat that most civilizations never survive? The answer has profound implications for our future. If the filter is behind us, we might be incredibly rare and fortunate. If it's ahead, then our future, and that of any emerging civilization, is perilous. One possibility is that the Great Filter lies in our distant past, perhaps in the very origin of life itself, abiogenesis. The transition from non-living matter to self-replicating organisms is an incredibly complex process, one we still don't fully understand. It's possible that the conditions required for life to spontaneously arise are so extraordinarily rare that it only happens once in a blue moon. Or rather, once in a galaxy. Another potential filter in the past could be the evolution of complex, multicellular life from simple prokaryote. This was a monumental leap, requiring specific environmental conditions and biological innovations, like the development of photosynthesis in eukaryotic cells. It took billions of years on Earth. Perhaps this evolutionary bottleneck is far more difficult to achieve than we imagine, making complex life exceedingly rare throughout the cosmos. Even if complex life emerges, the development of intelligence and technological capability is another massive hurdle. Evolution does not inherently drive towards intelligence in the way we understand it. Many successful species on Earth thrive without it. Perhaps the specific set of environmental pressures, genetic mutations, and cognitive developments required for a species to build radio telescopes and spacefaring vessels is incredibly unique, making humanity an anomaly. Now, let's consider the terrifying possibility. The Great Filter lies in our future. One of the most frequently cited future filters is self-destruction. As civilizations advance, so does their capacity for destruction, be it through nuclear warfare, runaway climate change, engineered pandemics, or uncontrolled artificial intelligence. Many civilizations might reach a technological peak only to collapse under the weight of their own creations, never achieving interstellar travel or communication. Another future filter could be resource depletion. Developing advanced technology and maintaining a large population requires immense resources. A civilization might exhaust its home planet's vital materials or energy sources before it can expand into space, leading to an irreversible decline. This would confine them to their home world, eventually dimming their technological light and making them undetectable to others. Cosmic catastrophes also pose a significant future filter. Supernovae, gamma ray bursts, asteroid impacts, or even drastic climate shifts on a planetary scale could wipe out a nascent civilization before it achieves interstellar capabilities. The universe is a dangerous place, and life, even intelligent life, might simply be too fragile to withstand its most violent phenomena for long enough to expand. Perhaps the filter is a technological singularity, where advanced intelligence evolves beyond our comprehension. Instead of expanding across the galaxy, these superintelligences might choose to exist in simulated realities or merge into a galactic superconsciousness, becoming undetectable or uninterested in communicating with less evolved species like us. Their existence might be so different that we wouldn't even recognize it as life. The Great Filter hypothesis offers a sobering perspective. If the filter is behind us, humanity is extraordinarily lucky. If it's ahead, then our future is a race against an unknown, potentially insurmountable challenge. Understanding where this filter might lie is crucial, not just for solving the Fermi Paradox, but for guiding our own choices and ensuring the long-term survival of our civilization. It forces us to confront our vulnerabilities and responsibilities. Another prominent explanation for the cosmic silence is the rare Earth hypothesis. This theory proposes that the emergence of complex, intelligent life requires such a precise and improbable combination of astrophysical and geological events that Earth might be an exceptionally unique, if not singular, case in our galaxy, or even the observable universe. It's not just about having water, but having everything just right. The rare Earth hypothesis suggests that our solar system is located in a galactic habitable zone, a specific region of a galaxy where conditions are optimal for complex life. Too close to the galactic center, and radiation from supernovae and black holes would be too intense, too far out, and there wouldn't be enough heavy elements to form rocky planets. Earth's position is just right, a cosmic sweet spot. Our sun is a remarkably stable star, providing consistent energy for billions of years. Many stars are flare-prone or have short lifespans. Furthermore, our solar system's architecture, with gas giants like Jupiter acting as gravitational shields, deflecting comets and asteroids, is also crucial. Without this cosmic bodyguard, Earth would likely face far more devastating impacts, making the evolution of complex life much harder. Earth's unique geological features are also vital. Plate tectonics helps regulate our planet's temperature and carbon cycle over geological timescales, preventing runaway greenhouse effects. Our unusually large moon stabilizes Earth's axial tilt, preventing extreme climate swings that could sterilize the surface. These are not common features on exoplanets, adding to Earth's rarity and the conditions necessary for complex, sustained life. The rare Earth hypothesis suggests that while simple microbial life might be common, the precise confluence of factors required for complex, intelligent, and communicative life is exceedingly rare. It implies that we might not be alone in the universe in terms of basic life forms, but we could be incredibly unique when it comes to advanced civilizations. This perspective makes our existence even more precious and our planet a true cosmic gem. What if advanced civilizations are out there, but they're deliberately avoiding contact with us? This is the essence of the zoo hypothesis. It posits that extraterrestrial intelligence exists and is aware of us, but they choose to observe humanity from a distance, much like we observe animals in a nature preserve or zoo. They might have a policy of non-interference, allowing our civilization to develop naturally without external influence. This prime directive of non-interference could stem from a variety of ethical or practical considerations. Perhaps they believe that contact would disrupt our natural development, lead to cultural shock, or even cause societal collapse. They might be waiting for humanity to reach a certain level of maturity or technological advancement before revealing themselves, deeming us not yet ready for galactic citizenship. An even more extreme version is the planetarium hypothesis. This suggests that the entire universe we perceive, the stars, galaxies, and cosmic silence, is a sophisticated simulation created by a super advanced civilization. We are living in a meticulously crafted virtual reality, designed to prevent us from detecting any external life or even realizing the simulation's true nature. Our reality is a carefully controlled illusion. From an ethical standpoint, the zoo hypothesis raises intriguing questions. Is it moral for a superior civilization to interfere with the natural progression of another? Would contact truly benefit humanity, or would it lead to unforeseen consequences? Perhaps the aliens are not just observing, but actively managing our environment, or even subtly guiding our development, much like unseen gardeners tending to a unique cosmic garden. While difficult to prove or disprove, the zoo hypothesis offers a fascinating explanation for the silence. It suggests that the absence of evidence isn't evidence of absence, but rather a deliberate choice by others. It challenges our anthropocentric view, implying we might be far less significant, or perhaps more cherished, than we imagine. It opens the door to a universe teeming with life, yet intentionally hidden from our view. Could it be that extraterrestrial intelligence isn't just observing, but is already here among us, or at least within our solar system, yet remains undetected? This hypothesis suggests that advanced civilizations might exist in forms or locations we simply aren't looking for or cannot perceive with our current technology. Their presence might be subtle, or so fundamentally different from our expectations that we miss it entirely. Imagine technology far beyond our comprehension. An alien civilization might use quantum entanglement for communication, rendering radio waves obsolete. Their spacecraft could be cloaked, moving at speeds or in dimensions we can't detect. They might reside in environments we consider uninhabitable, like deep oceans of icy moons, or within the atmospheres of gas giants, using energy sources completely alien to us. Our search for life is often biased by our own biology. We look for carbon-based life requiring liquid water. But what if life can exist in entirely different forms? Silicon-based life, plasma beings, or even purely energetic entities could exist. These forms might not leave the same footprints we expect, or might interact with the universe in ways that make them invisible to our current instruments and assumptions. Highly advanced civilizations might build Dyson spheres, megastructures, enclosing their stars to harness all their energy. Such structures would emit unique infrared signatures, which we do scan for. On the Kardashev scale, Type 2 and Type 3 civilizations command planetary and galactic energy levels respectively. We might miss their presence if their energy consumption is so efficient it leaves no waste heat, or if they are simply too far to detect. This hypothesis challenges our perception. It suggests that the reason for the silence isn't a lack of life, but a limitation in our ability to detect it. We might be like ants trying to detect an entire human city, using only our antenna. The universe could be bustling with activity, but it's operating on frequencies, scales, or dimensions entirely beyond our current comprehension. We simply aren't looking correctly. Now, for a truly chilling hypothesis, the dark forest theory. Inspired by Chinese science fiction author Liu Cixin, this theory paints a grim picture of the universe. It suggests that the cosmos is a dark forest filled with hidden predators. Every civilization is a hunter, armed to the teeth, stealthily moving through the trees. To reveal your presence is to invite destruction, as any other civilization you encounter is a potential threat. The core tenet of the dark forest theory is the chain of suspicion. Any civilization detecting another immediately assumes the worst-case scenario. The other civilization is hostile and will eventually pose an existential threat. Given the vast distances and timescales involved, direct communication or understanding is impossible. Therefore, the safest course of action is preemptive destruction to ensure one's own survival. The theory also incorporates the idea of technological explosion. A civilization might start small and weak, but could rapidly develop advanced technology. This makes even a seemingly primitive civilization a potential future threat if allowed to grow unchecked. Therefore, the optimal strategy for survival is to eliminate any detected life as soon as possible, before it becomes a danger to you or your species. In this universe, silence is not merely an absence of noise, but a strategy for survival. Every civilization that understands this principle would meticulously hide its presence, never broadcasting signals, never attempting interstellar travel that could reveal their location. The cosmic silence we observe is not emptiness, but the sound of countless civilizations holding their breath, terrified of being found. The dark force theory is a stark and unsettling resolution to the Fermi Paradox. It implies that our efforts to send signals into space, like the Arecibo message, might be incredibly naive and dangerous. If this theory is true, then the best strategy for humanity's survival might be to remain silent, to listen, but never to reply. It forces us to reconsider our place in the cosmos, not as curious explorers, but as potential prey. After exploring these complex theories, we must also consider the simplest, yet perhaps most profound, explanation for the Fermi Paradox. We are alone. This hypothesis suggests that despite the vastness of the universe, the emergence of intelligent, technological life is an incredibly rare phenomenon, perhaps even unique to Earth. The cosmic silence is not a mystery to be solved, but a reflection of reality. The we are alone hypothesis is often supported by the anthropic principle, which states that the universe's fundamental constants and laws are precisely tuned to allow for the existence of life. If these constants were even slightly different, life as we know it would be impossible. This fine-tuning could be seen as evidence that our universe is uniquely suited for us, making life elsewhere improbable. Earth's history is a long, improbable chain of events. From the formation of a protective atmosphere, to the timing of mass extinctions that cleared the way for new life forms, to the specific conditions that allowed for the rise of intelligence. Each step was critical, and each could have gone differently. The sheer number of low-probability events converging to create us might make us a statistical outlier, a cosmic miracle. Even if life arises frequently, the window for intelligent, communicative life might be incredibly short. Civilizations might emerge and disappear within cosmic blinks of an eye, never overlapping in time or space with others. The universe is ancient, and we are relatively new. Perhaps we simply missed the rise and fall of countless empires, or we are too early or too late to witness the next great cosmic awakening. The we are alone hypothesis is perhaps the most humbling. It places a tremendous burden of responsibility on humanity. If we are indeed the only intelligent life in this vast, silent universe, then the preservation and continuation of our species, our knowledge, and our unique perspective become infinitely more critical. We are not just guardians of Earth, but potentially the sole custodians of intelligence itself. Despite the daunting challenges of the Fermi Paradox, humanity has not given up its quest. Organizations like SETI, the Search for Extraterrestrial Intelligence, are dedicated to actively listening for signals from other civilizations. Using powerful radio telescopes, SETI scans the skies, hoping to detect any artificial transmissions that might indicate the presence of intelligent life beyond Earth. SETI's primary method involves searching for technosignatures, signs of technology from other planets. This includes narrowband radio signals, which are unlikely to be produced by natural astrophysical phenomena. They also look for optical pulses from lasers, or even subtle changes in starlight that could indicate megastructures like Dyson spheres. It's a needle in a haystack search, but one driven by profound curiosity. While SETI listens, METI, Messaging Extraterrestrial Intelligence, takes a more proactive approach. METI actively sends messages into space, hoping to make contact by broadcasting our presence and information about humanity to potential listeners. This is a controversial strategy, especially given theories like the dark forest, but proponents believe the potential benefits of contact outweigh the risks. The debate surrounding METI is intense. Critics, including prominent scientists and thinkers, warn against the potential dangers of announcing our presence to an unknown universe. They argue that we have no way of knowing the intentions or capabilities of potential recipients. Proponents, however, argue that the universe is vast, signals dissipate, and the potential for shared knowledge and understanding is too great to ignore. It's a gamble with cosmic stakes. Even before dedicated SETI, METI efforts, humanity sent messages into the cosmos. The Pioneer plaques and Voyager golden records, carried aboard these iconic spacecraft, are time capsules designed to convey information about Earth and its inhabitants to any extraterrestrial intelligence that might one day intercept them. These are our silent ambassadors, carrying our story across the vast, cold vacuum of interstellar space. The Fermi Paradox remains one of science's most enduring and captivating questions. We've explored various hypotheses, from the great filter that might lie in our past or future, to the possibility of a rare Earth, to advanced civilizations observing us from afar, hiding among us, or even seeing us as potential threats in a dark cosmic forest. And finally, the humbling possibility that we are truly alone. Each explanation offers a unique perspective on our place in the universe. While we currently lack definitive answers, the search continues. Every new exoplanet discovered, every faint signal analyzed, every scientific breakthrough in astrobiology brings us closer to understanding the true nature of life beyond Earth. The question of where is everyone continues to fuel our scientific curiosity and drive our exploration. Regardless of the answer, the Fermi Paradox underscores a profound responsibility. If intelligent life is common, then we must strive to be good galactic citizens, ready for respectful contact. If it's rare, then humanity's continued existence and thriving become even more vital. Our choices today regarding our planet, our technology, and our interactions echo across the cosmos, shaping our own destiny and potentially the fate of intelligence itself. The silence of the universe, rather than being disheartening, can be seen as an invitation to explore, to discover, and to understand. It pushes us to innovate, to look deeper, and to question everything we thought we knew. The quest to solve the Fermi Paradox is not just a scientific endeavor, it's a philosophical one, challenging us to define what it means to be alive, intelligent, and alone, or not alone, in this grand cosmic tapestry